For the next few things, I'm going to go through a deep dive into trigonometry. I'm going to start off with basic trigonometry, which is right-angled trigonometry. And it's what at GCSE or in year 9 or sort of 14 to 16 we call SOHCAHTAO. And SOHCAHTAO, it's easier if you write it like this, because sine of x equals opposite over hypotenuse. Cos of x equals adjacent over hypotenuse, and tan of x equals opposite over adjacent. So I literally write it like that, and that makes it much easier for me to not do anything wrong. SOHCAHTAO and trigonometry, particularly at this stage, is not hard at all. It's just a case of doing exactly what I'm about to show you. So we start off, we see where the angle is, and the angle is there. And now we mark up our triangle. And we know that the longest side that is opposite the right angle is always the hypotenuse. So this is H. We know that the side opposite the angle is O. And just because I'm marking it up, the adjacent side, i.e. the neighbour's side, the one that touches it, is A. Okay, now in this case, we know that we need X and 32 because they're already marked in. So mark the ones that you need. It's O and it's H. And if we know it's O and H, then mark up which one you're going to use. And it's going to be sine, or SO in this case. So now you write down sine of 60, and you always keep the angle next to the ratio, which is all that sine and cos and tan are. And I'll explain that a little bit more at some other point. So sine of 60 equals, then we put in O, so O is X, and then we put in H, which is 32. And then we know that we can't put this into our calculator. So what we're going to do now is X is being divided by 32. So if I said, what is 32 doing to X? You would say, because it's under that line, it's dividing it. So now we're going to times both sides by 32. Now, if you put 32 over 32, you get 1. So that means you end up with just X on its own, which is often what we're trying to achieve when we do this. So we times sine 60 by 32, and you don't times out the angle, you just times out whatever the answer might be. Now, the answer to 32, you can put this straight into your calculator. 32 sine 60 equals, and it's 16 root 3. Now, you're going to say to me that is that's an exact answer, centimetres. But you can actually find out. So it's 27.71, and it wants it to 3 significant figures. So 27, let's do 27.7 centimetres. Okay, so that's what we're going to do each time. Now we're going to find another one, and we're just going to do, again, the basics. So write down SOHCAHTAO. Mark up your triangle. So that's an H, that's an O, and that's an A. Find out what they want. They want A, B, so they want this again. So it's going to be that one and that one. So it's so again. So we say sine of 23 equals opposite over, or AB over 15. So it's 15 sine 23. And this one, weirdly, is not going to give us an exact answer because sine of 23 is not exact. So 15 sine 23 equals, and in this case it's 5.86. So we'll say 5.86, it goes 5.860, so 5.86 centimetres. Okay, let's find one other one that's really straightforward. Okay, this is slightly different but almost the same. So I'm just going to do one more like this. And I'm going to mark up, this is H, this is O. Again, this is exactly the same, so I'm not going to do this one because it's exactly the same, although you still have to go through this. Let's just see. Oh, that's Pythagoras, which is a different thing. Let's just find one more. Okay, let's try this one. Here is a part of a field. The farmer of the field, this part of the field is in the shape of the trapezium. He wants to put fence all the way around. Actually, that is Pythagoras as well. I know because there's no angles, or we're not even trying to find an angle. Okay, this weirdly is trying to find an angle, and it's not using sine, so it's good. So we write down SOHCAHTAO again. The diagram shows a ladder leaning against a vertical wall, and the ladder stands on horizontal ground. The length of the ladder is 6 meters, so that's this, it's the hypotenuse. And the bottom of the ladder is 2.25 meters from the bottom of the wall, okay. And that weirdly is adjacent because I think we're trying to find y. The ladder is safe to use when the angle marked y is about 75 degrees. About's very general, isn't it? Is the ladder safe to use? You must show you're working. So we filled in this, and now we've got to use backwards of them. So we've got the h and the a, so we've got cos. So if we say cos -1, and then we put in, this is what we're going to put into our calculator, a, which is 2.25, over 6, then this will tell us if it's about 75. It's a very weird thing to write, because surely it should say something is bigger than or smaller than, and which is better? Who knows? Anyway, so that's 2.25 over 6, which is... Ooh, that's only 67 degrees. So, oh, it's 67, it's almost 68, so we could go for 68 degrees. I don't know if it's safer if it's smaller, or I would imagine it's less safe as it gets bigger. So I think it might be safe. But, you know, I'm not a health and safety officer. So anyway, that's your little introduction to